We'd like to welcome you all to today's In Conversation with webinar. We're delighted to be working in partnership with Comau and our leading industrial automation company. We are joined today by Massimo Impolito from Comau and Phil Myers and Andrew Osborne from Pearson. We will cover the development of robotics in industry today, how it is changing the world of work, and the structure and importance of the BTech Award in Robotic Operations in supporting learner understanding. Over to you, Massimo.
Okay, thank you very much. So let me spend a couple of words about Comau. As Claire anticipated, Comau is a leading company which provides manufacturing solutions in different sectors. And this solution includes also our robot. We have more than 25,000 of robots installed around the world. We design and produce our solution in 13 different countries, which include also UK, with more than 50% of our population have a graduate education. So training for Comau clients and also for education system is fundamental. And that's why we have created this Comau Academy, where I'm responsible for the university relation. So if you can go to the next slide. The starting point of this conversation and my introduction is start from the consideration that with all these technologies around us, which includes, of course, also the robot, what are the jobs of the future and how the actual will change? I don't have, unfortunately, the crystal ball, but what is clear today is that with the rise of the robot, some of the job that we know will be eliminated. But of course, other jobs will be created in order to deal with the introduction of these new technologies, as robotics. So as this progress continues in the factories and also outside the factory, because the robots are not only in the factory, the blue collar and the white collar jobs will change and will change also the roles in the next 10 years. So today, robotics and automation are changing, of course, the role in the factory of blue and white collars, but it also creating new opportunities at all different levels. So the consideration is that these job profiles and these relative skills are changing very quickly. And that's why the training and education is important. And this will be both within and outside the traditional roles that today we know. So just to give you an example, in the next slide, we have a short video. Okay. So this video is very, simple, but it shows one, let's say, clear trend and how the robot are doing this repetitive task with every year an increasing speed and quality with respect to human being. So factory in Europe and around the world cannot work without human, but at the same time, the human have to work together with the robot. And this is a very, let's say, common trend around the world. if you go the next slide, Phil, please, you can see the trend of the robots which are installed on the left around the world. You can see that every year the number of the robots installed continuously increasing. So this is what we have said. So the industry cannot work without the robot, and let's say the human also cannot work without the robot. And the same trend, if you see the picture on the right, will happen in the same way also in UK and in all different countries. So the robot continuously to grow in every different kind of application from the industry, but also with a new generation of robots, which is called service robot, and not only industrial robot. They are growing also in other sectors. So that's is the consideration. If you can go to the next slide, is that company and industry, and not only industry, in order to stay competitive, to reduce the production cost. So this industry, they have to, and they must use industrial robot in order to increase the speed of the manufacturing process and reduce, of course, the cycle time. So rising the production efficiency. So as we have seen in the video, for example, the robot can do these repetitive jobs, and people can be used in a more creative way in order to improve the way to do the manufacturing in these days. So these repetitive jobs, if we look at the past, these repetitive jobs and the cost of these repetitive jobs are about 1/10 of the cost of 10 years ago. So the five potential impacts of the robot in the industry today are that first, as we say, and we reported here in this slide, the manufacturers are shifting to advanced robotic and flexible automation. This is clear. This is clear also from the picture that we have seen. But robot and automation will not replace our workers, but they will change, and they will change the skills and the requirements in order to have a higher skilled jobs. So the work of the people in the plant will not be the same. And this is an important point for the training. So the increasing using of robots and automation will significantly change the manufacturing jobs. And the industry and education must be prepared for this change. And this is the training is an important part. So manufacturing will continue to use the robot. And the problem that they have today is that manufacturers are struggling to hire workers, that there is a shortage of qualified workers with robotics and automation skill levels. And this trend will continue in the next year, will be more important. You can go to the next slide, please. There will be, for sure, 4 classic profiles that will be impacted by this, let's say, introduction of robotics and automation. So we will have a production operator, we will have a maintenance technician, of course, because with the introduction of technology, also the maintenance will change, but also the engineer and production manager. But the most important change will be at the level of the production of operator. And this will be produced by this rise of robotics and automation that will change over the next 10 years. So of course, we will have a complex application that still require specialized knowledge, but there are also trends where the robot will be easy to program, and especially in retask. And this will be done directly from the people and from the production operator in the plant. So there will be, let's say, 2 types of role that will in some way deal with the robotics. So the people that will program the robot for complex tasks, and the production operator that will maintain in some way and reprogram this robot. So the production operator will be increasingly involved in, for example, in training the artificial intelligence algorithm. So what you have seen in the video is something that has been programmed by people, by human. This program, even if we have today this artificial intelligence, still this artificial intelligence need the human that is used to let's say training this artificial intelligence. So production operator will be involved, for example, in training the robot in application side, like the application we call pick and place, so the most easy. But production operator will be also central to design and adjusting the process, for example, to incorporate these new robots, the collaborative robot, and in order to, let's say, incorporate the robot as a human assistant, so as a collaborator. So the International Federation of Robotics members, so all the companies like Comau and the other that are involved in the design and production of this robotics technology, believe that these production operators will change the role and they will need new skill in the next 10 years. And this will be, let's say, the more significant benefits for production and for the workers in production. To give you an example, in the next slide, please, Phil. The production operators today, but also in the next year, will work with the robot. There will be this, as we say, collaboration between the human being and the robot. So the factory cannot be what we say a dark factory, a factory without human. This is something impossible. Of course, most probably industry like to have this kind of dark factory, but this is impossible because the robot should be programmed and the robot need assistance. But the most interesting scenario is not this dark factory, but a factory where the robot and the human collaborate together. So the International Federation of Robotics estimate that 50% of the, let's say, the human will be working with the robot in the next 10 years. So it means that our factory, as we know the factory today, will change a lot. This task for the production operator will include programming simple application. So it means that someone in Comau will program a robot. We do this complex programming, but the people in the plant will continue to improve the application that we will generate. So the production operator will be involved in monitoring also the robot performance. So they will be involved also in some work that they will do together with the technician of the maintenance. But at the end, they will collaboratively work with the robot. And in all this, let's say, change, they of course, they have the opportunity to learn new skills. So that's why in the Comau Academy and with Pearson, we have created this, let's say, training on the robotics. And all, let's say, this new skill will be used across a different range of production cell of line. This is basically which is the role and the new role of the production operators, but also the role, sorry, for the engineers. So this is important for engineers that will come out from different level of school and also from maintenance technicians. So this will start with the basic comprehension of robotics, but also will start with the comprehension how to program deal with the robot. And this is the, say, the program and the training path that we have defined together, because this is an important part, say, and about the training, there is the core of the next say, factory of the future. So and the introduction of this technology in the future factory, not only in let's say in UK or the other, but this is something that will involve at a different level of also different kind of industry and sectors everywhere. Thanks, Phil.
Thank you, Massimo. So it's a really sort of interesting and I think relevant oversight of what's happening in robotics and what the future looks like. And this is, you know, the central sort of motivation for Pearson to work in partnership with Comau to develop this qualification and learning support. And we very much see this as a whole package of support for you. What we've done is develop a BTEC program which complements the Comau robotics software, and I will show you a little bit of that so you can have a sight of what the actual learning materials look like. But what we've done is to create 4 units which match exactly with 4 Comau learning modules. And those are modules which learners will log into. They'll log into our Pearson Learning Hub, and they'll work through these learning modules on computer. So there's an exact alignment between the BTEC unit and the Comau module. The program is 55 hours of duration, so it's a short program. And the design of the program, as Massimo has alluded to, is very much to give a real practical industrial showcase of how a robotic arm is programmed. So it's not a big discourse on the underpinning history of robotics, etc., etc. It's a real practical vocational application. So this is how a particular robotic arm is programmed. So learners get a real insight and understanding of robotic arm manipulation and programming. If you're not familiar with BTEC, the way that we structure our BTECs is in a unit fashion. So we split our content into units. As I say, these 4 units are each associated with the 4 student resources. And each of those units will have a set of learning outcomes, which state what a learner will be able to know, understand, and be able to do on completion of that unit. And then each of those learning outcomes are then assessed by assessment criteria. And those are the assessment standard which a student needs to meet in order to achieve that unit. For this qualification, we've set those only at pass, so we haven't set grading in this qualification. So it's quite a simple model, we feel, and one which we hope will be accessible and accessible for both teaching and also for the learners. Within that, the model, we have an assignment, and what learners do is complete that assignment, and that's graded for pass, and then the learners can be certificated and they can receive their BTEC certificate. We've provided for you a sample assignment which you can use, so it's an authorized assignment, and you can use that. And what you can do is that assignment can sit right at the end of the course. So we often with BTECs we split the assignments for each unit. So you'd have to assess each unit as you go through the program. But because it's a short program, that assignment can be tackled at the end of the course of learning. All of this material and all this support is in Learning Hub, and I will show this to you. Also, just to add that this is an international qualification. It's available for international centres, not necessarily UK based. It's available across the world. So the design of the BTEC program. So as I say, these are the units which align with the Comau training materials. So Unit 1, Robotics Systems and Basic Procedures. So within this unit, they're looking at the main components of the Comau system, the teach pendant. So that's the mechanism which is used to control the robot, and the robot control unit itself, in terms of how that is used and how that can be manipulated in order to move the robotic arm. Unit 2, field bus and reference systems. So the key inputs and outputs, the 3D reference systems, using robotics calculations. All of this is gearing up to supporting the learner to be able to program the robotic arm to move in the desired way. This is that underpinning knowledge which is going to support them to do that. Unit 3 is motion programming. So they develop robot programming and create structured programs. So very much sort of getting in there, looking at the programming language, thinking about how they're going to move and what the outcomes of those movements are in terms of the robotic arm operation. And then further robotic programming, so a more sort of problem solving approach. So, you know, realization that, you know, these movements are designed for particular outputs, and therefore supporting learners in understanding how that would work. So supporting the wider curriculum, and Andy will give a bit more detail of this a bit later on. But very much we see this, as I say, as a specific vocational use of a robotic arm, and the opportunity for learners to actually engage in that programming and understanding the way that programming works on the robotic arm. So we see this the potential for this for apprentices, possibly graduate trainees, perhaps in associated industries if you want to develop understanding of specialist robot knowledge, but also sitting alongside level 3. When I say level 3, I'm talking about those 16 to 18-year-old learners prior to university level, prior to upper vocational levels, where this as a shorter course can complement that longer period of study, and as I say, give them a real sort of vocational sense, that vocational application of the robotic arm in industry. So Learning Hub resources. So if you'll bear with me, what I'm going to do is just come out of the presentation, and I'm going to actually go into Learning Hub, so that I can show you the resources within Learning Hub. So those of you who are familiar with Learning Hub, you'll know that when you get access to Learning Hub Pearson, you'll log in, and this is the screen you'll see. Pearson lists all of the resources which are available for the courses which we do, and then you click on to the course desired, which is Robotics Operations for us. So I'm in the teacher view here, and as a teacher within Learning Hub, you get an overview of your class. So what you'll be able to do if you've enlisted for Robotics Operations, you'll be able to see what your class is doing. There is a class engagement button. You'll be able to see when your students who are named here last visited, how long they've been in the materials for, if they've done any tests, you'll be able to see grades, etc. And there's discussion opportunities within Learning Hub, so you'll be able to see that discussion. Hopefully it's work-based, but you'll be able to see that in Learning Hub as well. You can email the class, etc. So you get a real sense, I think, as a teacher of what your class is doing and a real sort of oversight, and you can support them in that engagement. It's, you know, it's really useful sometimes for them to have discussion within the learning. So within robotics, we've got the list of modules. As I say, with these modules, module 1, module 2, module 3 and 4, these are very tightly aligned with the BTEC. So the BTEC is structured in 4 units. You've got the 4 modules within the Comau materials. There's a one-to-one relationship, and by covering the modules for the most part, they're covering the underpinning knowledge they need for the qualification. What we've done is also to include some really useful information within Learning Hub. And one thing I'd want to draw attention to is the RoboSim. So within this training, there are 2 options. One is a robotics simulator. So there's an opportunity and a requirement, really, I think, for you to use a robotics simulator or to use a hardware robot. Now, the hardware robot does come at a cost, and we appreciate that you know, some of you will want to use the robotics simulator instead of the hardware robot. We require that you use one or the other. The simulator can be downloaded, and we've got all the links to support the download of the simulator. There are FAQs about how to run the simulator, technical requirements. All the information is here on Learning Hub to support you in terms of using the simulator. I'll just go into the software instructions. So we put minimum hardware requirements, etc., recommended hardware requirements. So yeah, what you do is you download the simulator, and then learners can manipulate the simulator. They can put the programming code into the simulator, and they can see the robotic arm operating. There is a hardware option as well, and there is support on here about how you would use the programming software to support the hardware. So there are 2 options for you. One is use of the simulation. One is use of the hardware. So the choice is there for you. The other thing I wanted to show you, as I've mentioned, there's an authorized assignment. So this is an assignment which we've set already for you, and this assignment you can just pick up and use. At the end of the program, at the end of the course of study, the 55 hours, learners can start that assignment, or you can get them started earlier on if you want them to think about after each of the modules, each of the units, and start putting together their evidence for the assignment. So that is set up and ready for you to use, and learners will complete the assignment, be graded on that assignment, and then they will get their BTEC certificate. We've also put in a schedule of work, and I just wanted to draw your attention to this. So this is for the teacher, and what we're doing here is suggesting how you can use the resources. So there are opportunities in the resources for you to just come out of the resources, allow for a little bit of class discussion, and maybe some points of technology, etc., where there's a benefit to the class of being able to have that conversation, benefit to you to be able to, you know, confirm some of their understanding. So we've structured a schedule of work so that you can use the resources and structure the teaching and learning, and also integrate the assignment as well. So this is a pick up and use piece of information which we thought will help you in terms of delivering the course. So I just wanted to drop into the course itself. So we just have a quick look at the module itself, so that you can get a little bit of a sight of how it looks.
Let's get acquainted with the robotic system and its main components through this video.
So that most of these, there's a series of screens. Most of these are screens where they will follow on. The screens will follow on. So learners will click into the module, they'll start it, and then the screens will follow on naturally. There are some exercises, there's some hotspots, there are little quizzes, little opportunities for engagement throughout. and there are video presentations as well. So there's plenty of opportunity for learners to be engaged in the resources. They're quite sort of dynamic in that respect.
A standard robotic system consists of a mechanical part, which corresponds to the robot and consists of an anthropomorphic mechanical arm, an electrical part needed to manage the arm, control unit, an interface device that allows to communicate with the arm and control unit, teach pendant.
So I won't play all of that, but you'll just get a little sense there, I think, of the resources. So I'll just come out of this. Oh, excuse me. There we are. Yes, so yeah, so that's the modules. That's the course. All of the support here in terms of the learning, and all of this is available for you on Learning Hub. So I'm just going to go back into the presentation. Yeah. So as I've said, qualification, it is suited for blended learning. The modules, the Comau modules, the student resources sit very tightly with the BTech unit. But as I say, with the schedule of work, there's an opportunity to, you know, structure a little bit of class discussion, opportunity to situate the assignment and the assessment within the course of learning. That can be taken as a single assignment at the end of the course. As explained about the robotic arm and RoboSim, so that's a piece of downloadable software which allows learners to manipulate a robotic arm on screen. There is also the opportunity to buy a robotic arm if you prefer to have that in class in your work studio. So, you know, there are some options here in terms of how you support that dynamic representation of the robotics. And of course, you know, we always recommend linking in with factory tours, with you know, seeing robotics in action as Massimo has described, so that learners can really see how robotic arms are so central in manufacturing processes. So I think I've explained the assessment. So each of the units has learning outcomes which also have assessment criteria, and we have an integrated assignment which supports the assessment. That can be taken at the end of the course, or you can start to sort of get learners thinking about their assignment as they're going through the four modules. Yeah, and just really in summary, I think this is a sort of contemporary industry relevant application of robotics. If you know our international level 3 BTEC in engineering, we do have a robotics unit in that, but this is a play through of that, if you like, in terms of, you know, how a robotic arm is actually used and programmed in industry. So it's an application of that. So we feel that this course really sort of supports an engineering program at that 16 to 18 age range. We explained about the simulation and the robotics arm, the assessment and the teacher support. So you see all that teacher support is available on our Learning Hub. So really, thank you very much. We've got some questions. So we've got Andy Osborne, who's joined us with from the Pearson team to support on some of your questions. Hopefully we've tackled some of your questions as we've gone through. We did receive quite a few questions in advance, so thank you so much for that, because it really does help to for us to sort of try and tailor our presentation to address some of the questions that you have. Do drop any more questions into the chat. We'll try and answer those as we go through. But first off, I'll just pass over to Andy for this question.
Yeah, so one of the questions we've had pre-submitted is how can I align the robotics units and the short course with the wider curriculum, for example, other BTEC units or maybe even academic subjects such as A-levels or local equivalents. So if we look at the slide that I've put up there, this is where robotics ties into a number of different areas. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 different possible areas where the robotics qualification could act as a context and a tool to bring in other qualifications. It's very tempting to sit in a robotics lab and just teach robotics, but a plan and a sensible integration of other teaching staff, technicians, other areas will allow other subjects to be taught with the robotics as a text. For instance, health and safety is a topic on its own for robotic integration. As Massimo touched on earlier, robotics is becoming collaborative, so there will always be humans involved, whether they be operators alongside the manufacturing process, technicians working on the robots, operators loading and unloading parts, and safe working with robotic arms and the associated guarding and electronic safety systems that go alongside that are a major part of robotic implementation, especially when you go to a factory level. So there is opportunities there for students to work on risk assessments. They could write safe operating procedures. They could research local legislation and guidelines on robotic integration. So again, there's a lot of things that you could use your robot as a context and a tool for, but not necessarily just stick to the robot qualification itself while using it. The next one below that, mathematics. Unit 2 in the qualification requires learners to understand 3D reference systems, because obviously the robot is moving in 3D space. The robot will be required to pick up items and put them down again. So then you're looking at forces, vectors, turning moments, all these sort of things. You need to be able to calculate the maximum weight that you can lift. That's called payload. And again, there are a number of different calculations regarding how much you can lift, how far you can extend the arm while it's lifting. All sorts of three-dimensional mathematics and mechanical principle subjects can be taught, again, using the robot arm as a tool. Even maybe when it doesn't appear that it's obvious and quite so technical, if we look at the top right topic on the slide, I have previously taught a business unit with a lot of reference to robotic integration, because as Massimo touched on, they are a tool which will increase production. There is a cost associated with buying a robot. So immediately you've got subject teaching around cost benefits, how much it costs to buy a robot, how fast production and when you get your return on investment, and even ethical considerations such as how to retrain staff, or whether staff may be lost due to robotic integration. So hopefully this slide gives a bit of a touch on where you could include your robot in other teaching, and we would obviously be more than happy to expand on some of these areas if required.
Brilliant. Thank you, Andy. So I'll just move on to the next slide. Yeah, so the next question, I think, Andy, this is one you were going to tackle as well, is that right? Yeah, the question really asks about the fundamentals of robotics and how the BTEC system and this qualification
look at the fundamentals of robot systems and prepare learners to understand those. So the best place to look at that in context is Unit 1, which is effectively the introductory unit. The learning outcomes you can see there, A, B, and C, are effectively fundamentals of robotics. Although we're using the Comau system to focus in on that, then each of these topics are fundamental to robot integration and automatic production in general. So the screen that Phil put up on the Learning Hub earlier was the first slide of the first outcome, which introduced a robotic arm, a teach pendant, and an electronics control unit. And again, although they are Comau, that is a standard setup for robotic integration across many different industries and aspects. So again, although we are using Comau as an excellent learning tool to be able to facilitate this qualification, many of the principles that are touched on throughout are fundamental robotics principles, which are generically useful across different robotics manufacturers and across different applications and industries. And again, as Phil said, the BTEC system is specifically designed for a soft introductory start. You don't go straight into robot programming and complicated techniques. The first unit is a generic unit to show how robotic systems are within the world and how you would understand the robotic items. Unit 2 builds on that and shows how they fit in larger automated systems. And then units 3 and 4 introduce programming and up the level of technical requirement and skills that the learners develop. So it's very much a ramped approach, starting with fundamentals and ending with some really high-level technical programming, which should be transferable across different applications and different industry sectors.
Brilliant, thank you, Andy. And I think with the, for those of you not familiar with BTEC, you can see from the screen a sense of how BTEC is put together. So learning outcomes and then the assessment criteria, which is really the assessment standard which learners will meet. And as I say, with the assignment we've developed, we've created an assignment which assesses those assessment criteria. And you will have picked out that some of those are more demonstrative. Well, we've built that into the assignment as well, so that learners are demonstrating those skills, be it with the simulator or perhaps with the hardware robot, as well as showing some of their knowledge and understanding of the assessment. So final question, do I need to teach all this content in the classroom or can learners access the modules at home? So the Learning Hub is accessible from home. So you can sort of set homework, so you can set a part of the resources homework. Students have their own access, so you can control the level of access that learners have, so that learners are may just want them to do a small hour or whatever of the resource. So you can control their access in terms of how they access Learning Hub. So yes, there are opportunities for content to be accessed at home, and as we've said, there is a blended element of this as well. So you can take them out of the resources and get them to have some discussion, and so that you can support them in terms of some questions which may come up. So Claire, I just wondered if there are any questions in the chat.
Yeah. So we've had a few in. So we've had a question about how many guided learning hours is per unit.
Yeah, so it's Yeah, it's roughly 10 to 15. So some of the units are slightly weighted because of the particularly towards the end of the program. So as Andy was saying, this is a staged program. We don't sort of drop them in at it right at the start. We do sort of introduce the concepts, introduce that familiarity, and this is all, you know, this is how the Comau modules have been designed. So, but towards the end of the resource, the slightly larger units exist because that's where they're doing the more practical and programming content.
And then there's just one on the RoboSim software license, and how much does it cost per license? Is it?
There's no additional cost. There's no additional cost. So when you buy this program, that's a freely downloadable piece of software. So it's included within this purchase. There is an additional cost for the robotic arm. As you can imagine, it's quite a substantial piece of machinery. Yeah, so yeah, that is, if you are interested in the robotic arm, then, you know, let us know, and we can discuss with you shipping and prices.
And I think that's it for the chat. If anybody has anything else to add it quickly, and we'll just stay on the line just for a few more minutes.
Yeah, I just wanted for this opportunity, Massimo, to from your side, how we've been saying that this is representative of the robotics industry as a whole. Is that right from your perspective? So what we're saying is that when they do this robotics course, they get an understanding which they can then apply into any number of different robotics functions in terms of operating that robotic arm. But is that correct from your perspective as well?
Yeah, yes, Phil, it is. It is. I mean, the course is general. Of course, we have taken as a, say, practical example a Comau robot, but say all the different robots from, let's say, our competitors are very similar. So yeah. The point is what they learn in this kind of training program can be, say, adapted in also with other different kind of robots.
Thank you.
Of course, there will be, let's say, some manuals, some let's say typical part of each different let's say robots, but it is like to drive a car. I mean, you know, when you know how to drive a car, then of course you need sometimes to get used to the different dashboard.
Yeah,
the same. I mean, the same concept. You know?
Brilliant, thank you.
We've had a few more questions in. So question, is this course suited to learners with no previous knowledge of engineering software programming?
I can take that if you... Yes, shall I take that? Andy. Yeah, sure.
Yes, please do.
Yeah, so having taught robotics for a good number of years now as part of an engineering course, it's a very easy unit to put anywhere in a course. So you can put it at the start of course, in which case learners are new to engineering. And it's a nice practical start to their engineering education because there's not much theory. Most of it is trying and learning as you go. So there is no maths requirement for it. There's no electronics or mechanical engineering requirement for it. And as I touched on earlier, it's a good way to introduce non-engineering students to the world of engineering and show them how different disciplines react with each other to form an overall engineering application that they will probably be familiar with, because they will have seen videos on car production and maybe even food and drink and beverage production with bottles going along lines, these sort of things. So it does lend itself to a non-engineering student and a good way of introducing them into the world of engineering. Or if the students are students already, it's great to put near the end where they've done some maths, they've done some electronics, they've done some mechanical principles, and they can see how previously contextualizes itself into a real world application. So yeah, I've taught robotics for a long time, and it sits very well anywhere within an engineering program.
Thanks, Andy. And then just one about, do they have to apply for the approval if we are already a BTech centre?
Yeah, so I'll answer that. With this, if you're already a BTech centre, all you need to do is apply for the new qualification approval for this, and so it's an additional qualification onto your portfolio. So you would have done all of the centre approvals. That's all sorted for you. It's just an additional qualification approval.
Yeah. So thank you for joining today's session. We hope that you found it useful. What we will do is we'll circulate a recording of the session and the slides and any key information, so links to any key information that we've mentioned, and also links to the Learning Hub demo. So if you wanted to request a further in-depth demo of that, you can do. We'll also include an FAQs document as well, so all of the questions that we've had pre-submitted with written answers, and those that have come up during the session, we'll make sure that is shared with everyone. Thank you, everyone, and bye-bye.